So the next lesson in Module 7 is Lesson 7.7, and this is write and solve multiplication and division inequalities. As you can see, our learning target, I can use inverse operations to solve one-step multiplication and division inequalities with positive and negative coefficients. And what we're going to learn, the vocabulary. Now we have the division property of inequality and we have the multiplication property of inequality. Basically, it's exactly again how we had done in equations. Opposite of multiplication or the inverse of multiplication is division. Inverse of division is multiplication. And to counteract that, we use for example, if I have a number like this, I have 8x. That means multiplication. So the inverse would be the division property of inequality, where I would divide the same number on both sides of the inequality in order to solve it. Okay. If I had division, I would do the opposite, which would be multiplication property of inequality by multiplying the same number on both sides of the inequality. Okay. So let's do these two examples. So after writing the inequality, as I can see, we have 8x is less than or equal to 40, and that is the coefficient. This means multiplication. So we are going to do the inverse of multiplication, which is division. I am going to divide both sides by 8. Okay, 8 divided by 8 gives me 1, and 1 times any number is the number itself, so that would be x is less than or equal to, and 40 divided by 8 gives me 5. Okay, so x is less than or equal to 5. So what I'm going to do over here, I can check my solution by substituting a number less than or equal to 5 into the original inequality. So to check my work, I'm going to take the original inequality, 8x less than or equal to 40. So a number less than 5. So let me just replace x with 4, because I know that 4 is less than 5, right? So 8 times 4 should be less than or equal to 40. And what is 8 times 4? And I have 32. Is 32 less than 40? Absolutely. Is it equal to? No, but it is falling in that inequality of being in a solution which is less than or equal to 40. So that is correct. Okay. And to graph this, remember, we're going to put values here. If x is equal to 5, that means 5. Less than 5, that means 4, 3, 2, etc. All these numbers are less than 5. So I know that my graph is going to the left. Okay. So if I'm graphing it, 6, 5, 4, 3, 2, etc. And I said that x is less than or equal to 5. That means 5 is included. So this is going to be a closed dot or a closed circle. And everything to the left of that is going to be a solution to this inequality. Okay. Let's do the next problem. And that one is d divided by 2 is greater than 7. So now this is division. What is the opposite of division? It is going to be multiplication. So I am going to take this and I am going to see it's divided by 2. So I am going to multiply both sides by the same number. Okay, so when I look at this, how can I write 2 as a fraction? It can just be 2 over 1, and then I simplify, right? So I'm just left with d, and d is going to be greater than 7 times 2 is 14. Okay, so D is greater than 14. Now, in order to check my work, I am going to replace D with a number greater than 14. Now think of whole numbers. The first number I'm thinking of greater than 14 is 15. 16, 17, etc. Right? So I'm going to just substitute the value when I am checking my work, and I'm going to say D is greater than 14. So let me go ahead and use any number. So let's say I say 15 is being used for D. So if I say 15, I can say 16. It doesn't matter. I'm just using a number which is greater. So here was my original. It was D over 2 is greater than 7. So let's say I use 15. 15 over 2 is greater than 7. What is half of 15? If I divide 15 by 2, I get 7, and 5/10 is greater than 7. So is that correct? Yes, because 7 and 5/10 is definitely greater than 7. Now, if I had to graph this, I am going to, let me just graph it here so I can show you. All right. So here is, it's got to be greater, D is greater than 14. So if I have 14, 15, 16, 17, etc., is D included? No, it did not say D is greater than or equal. It just said D is greater. So I'm going to have an open circle, and everything to the right of that is going to be a solution. So that is the graph of the inequality. D over 2 is greater than 7. Okay. Um, now, one thing that you really need to know in this is, I would like you to just look what I've written on this side. When you divide or multiply each side of an inequality by the same negative number, okay, again, when you divide or multiply each side of an inequality by the same negative number, the inequality symbol must be reversed. So the inequality symbol must be reversed for the inequality to remain true. So let's talk about, I'm going to show you an example what this means. Okay, but this is super important. That's why I left it over here. Um, okay. So if I give you a problem, negative 2x is less than 10. Negative 2x is less than 10. So now look, what do I have? I do have a negative number. Okay, I have a negative number over here. It's a negative coefficient, right? So when I am looking at, this is multiplication. Okay, so opposite of multiplication is what? Division, right? So this is what it means. I am going to divide both sides using the division property of inequality. But since, look what it said, when you divide or multiply each side of an inequality by the same negative number, okay. Let me just do this on the next line so that you can see what I'm talking about. Negative 2x, and then I have 10 over here, and this was this, right? So when I'm dividing by the same negative number, in this case, the inequality symbol must be reversed. So look, reverse means this now is going to become this way. It's reversed. So instead of this, it has to be reversed. So this symbol has to be reversed when I am multiplying or dividing by the same negative number. Okay. And now we are going to solve it just like we did earlier. Negative 2 divided by negative 2 is 1, and so x is greater than 10 divided by negative 2, positive divided by negative, so I get a negative quotient. So there we go. All right, so this is the most important thing to remember. You've got to reverse the inequality also. Okay, now, we can check the solution by writing the inequality and then replacing it or substituting a number which is greater than negative 5 into the original inequality. So if I was checking, okay, so I have negative 2x. All right, negative 2x is less than 10. And so it should be a number which is greater than negative 5. So let's replace negative 3 because negative 3 is greater than negative 5, right? So I'm just going to say negative 2. I'm choosing any number which is greater than negative 5. So I'm saying times negative 3 should be less than 10. What is negative 2 times negative 3? That is going to give me 6 because negative times negative gives me positive. Is 6 less than 10? Yes, absolutely. So therefore, this is the correct solution. For me to graph this, I am going to have, it says x is greater than negative 5. So when I'm thinking about the negative side, negative 4, negative 3, negative 2, all these numbers are going to be greater 1, 0, 1, 2, etc. So as I can see, my graph is going to the right. Okay, so if I was graphing this, I would have my negative 5, right? So if I said negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, etc. So now we look at, it said is greater than negative 5. So therefore, if it's greater, is the negative 5 a closed or open? It's definitely going to be an open circle because negative 5 is not included. Okay, and so, and everything to the right of that is going to be a solution to this inequality. Okay. Um, let's do another problem really quick. So let's say our question is x divided by negative 4. X divided by negative 4 is greater than or equal to 3. Okay, so once again, we are looking at what it said over here. When you divide or multiply each side of an inequality by the same negative number. So if I am doing this one, I have x over negative 4. I have this. Okay, so since I'm dividing by negative 4, in order for me to get rid of this, so opposite of division is multiplication property of inequality. I'm going to multiply both sides by negative 4 times negative 4. And when I multiply, what happens to the inequality? I am going to reverse the inequality. I am going to reverse the inequality because I am multiplying with a negative number. Okay, so once I've reversed it, I get negative 4 divided by negative 4, which is 1 because this becomes over 1, right? And so x is going to be less than or equal to negative 12 because positive times negative is going to give me negative 12. So you can again check the inequality by substituting a number which is less than or equal to negative 12 into the original inequality. So again, here check. Okay, so I have x over negative 4. X, so I'm checking my work now. X over negative 4 should be greater than or equal to 3. Here's my checking. All right, and so I'm just going to replace x with negative 20 because I know that negative 20 is less than negative 12. So if I take negative 20 and I divide it by negative 4, it should be a number which is greater than or equal to 3. So what is negative 20 divided by negative 4? It is 5. So 5 is greater than equal to 3. Is 5 equal to 3? No, but it is greater than 3. So therefore, this is the correct solution. Okay? And then we can graph this on the number line by looking at x is less than or equal to negative 12. That means if I have a number line like this, what is equal to negative 12 is going to be negative 12. What is less than negative 12. It's negative 13, negative 14, negative 15, etc. So I know the graph is moving to the left, okay? So let's say I put negative 12, negative 13, negative 14, negative 15, negative 16, etc. And now, since negative 12 is included because it says less than or equal to, this is going to be a closed dot or a closed circle, and everything to the left is going to be a solution to this inequality. Okay. And then, we have word problems, which are, in the real world, where we can just use an inequality in order to solve it. Like I was talking earlier about driving example, at most, so much to ride a roller coaster, etc. So let's say Ling earns $15 per hour working at the zoo. So $15 per hour. Let the X represent the hour. Okay. Working at the zoo, write and solve an inequality to determine the number of hours Ling must work in a week to earn at least 225. Okay, so how much should he earn to earn at least 225? So we are going to first, what's the at least means what? The minimum amount that he should be working. Okay, so 225 is over here. This is at least, so that means the minimum amount, and so this has got to be this much. Okay, so this means at least, or it's the minimum amount. Everything else is going to be greater than that. So that is why the inequality is facing in that direction. Okay, so now we are going to use the division property of inequality, and I'm going to divide both sides by 15. 15 divided by 15 is 1, and then I have x is greater than or equal to 225 divided by 15. I get 15. Okay, so when we are looking at this, the solution is x is greater than or equal to 15. And so if I am graphing this solution, okay, if I'm graphing this solution, I have x is greater than or equal to 15. So that what is equal to 15 is 15. What is greater than 15? I have 16, 17, etc. Okay, so therefore I am just going to say, let's say this is 14, 15, 16, 17, 18, 19, etc. So if I am saying is equal to or greater, it's going to be a closed circle at 15, and then everything else, this is a closed dot or the closed circle, everything to the right of 15 is going to be a solution to this inequality. Okay, so that means so Ling must work 15 hours or more in order to earn that much money. Okay, let's do one last problem. Miss Miller is buying wax to make candles. So Miss Miller is buying wax to make candles. She wants to make at least 35 candles. Okay, and needs 6 and 5/10 ounces of wax for each candle. Write and solve an inequality to determine the amount of wax she needs to buy. And then we look at the solution. Okay, so she wants to make at least, that means 35 is the minimum. 35 is at least, which is basically what? The minimum amount that she needs. Okay, is going to be minimum. That means everything else is going to be greater than or equal to that. All right. And she wants to make 35 candles. Okay. So yeah, so 35 candles needs, she needs 6 and 5/10 ounces of wax for each candle. So how many candles is she going to use? So basically, for each candle is 6 and 5/10. So then we are going to see how many is going to represent that X, and that's basically telling me how many ounces of candle wax is she going to need. Okay, so once we write it out, we are now going to use, because this is division, multiplication property of inequality, multiply 6 and 5/10 times 6 and 5/10. That's basically what we're doing. This and this cancels each other out. X is greater than equal to 35 times 6 and 5/10 is going to give me 227 and 5/10. Okay. And so the solution of that inequality is X is greater than or equal to 227 and 5/10. Miss Miller needs at least 227 and 5/10 ounces of candle wax. And so if I was graphing this, what is equal to 227 and 5/10 is 227 and 5/10. 200, then what is greater? 228, 229, 230, etc. So we know the graph is going to the right. Okay, so if I have 227, 228, 229, 230, 231, etc. And then I know that 227 and 5/10 is going to be bang in the middle of 227 and 228. And since that is included, it's going to be a closed dot or a closed circle. And then everything to the right of that is going to be a solution to that inequality. Okay. So again, Mrs. Miller needs at least 227 and 5/10 ounces of candle wax. So this is basically writing and solving one-step multiplication and division inequalities. Please remember the most important part, especially when you are dividing or multiplying each side of an inequality by the same negative number, the inequality symbol must be reversed for the inequality to remain true. And that is with the negative numbers. If it's only positive, positive doesn't matter. But if we are doing that with a negative number, do not forget to reverse the inequality. Okay. And that is the end of lesson 7.7.